Okay, surface area is outside, volume is in. But to try and break it down into two pieces that hopefully beyond algebra and further on out into your lives, you guys can remember easily, okay? If you think of those little unit cubes, the ones that sometimes some of you maybe played with, put together, you can link them up. They're 1 by 1 by 1 Unifix cubes.
Oh, I thought you were talking Lincoln Logs.
Well, cubes. They have to be cubes, okay? With the same length, width, and height, basically. If these were all unit cubes, okay, to talk in terms of volumes, if we could cover the bottom layer with those unit cubes, and they're all 1 unit each direction, okay, then the number that we could fit in on the bottom really would be considered our base area. Does that make sense? How many we can fit this way and that way, okay? So if we can find the base area, length times width in this case, we would know how many cubes cover the bottom layer. Then the question would be how many of those layers do we need to fill up the height, fill up to the top. So as we're adding up those layers, okay, say there were, what this appears to be 5 times 4, okay? So if there are 20 cubes on the bottom, and then it takes me 10 layers to fill that up, then I have 20 times 10, which is essentially times the height, right? Yes?
Yeah.
Okay, so what I'm multiplying by here is my height, because those are all single units as well. So the big, and the height answers the question, how many layers of our base area? So the general idea of the formula for volume of a prism or cylinder, now the cylinder might seem different because those are circles and we wouldn't fill them up with cubes, but the same idea applies. If you could find the base area, then it's just a matter of how many layers of that do we have. So we're looking at our base area times the height of our prism. And again, just like it was with surface area, your height has to be the vertical distance between the bases, okay? So if we're looking specifically at a rectangular prism, and we've got dimensions 3 by 5 for our base, and a height of 5, then our base area is really talking about this rectangle right here, which would be 3 by 5, and a height of 5 as well. Okay, so our volume is 75, let's just call this meters, and now your area on the bottom is square units, but as soon as we add that third dimension, we are now into cubic. Okay, it would take 75 cubes to fill up that box. Okay, so volume should always be in cubic units. And the same things apply as they did with surface area. You still have to know what kind of figure you're looking at. You still have to determine what your bases are. It's not always sitting on the base. Okay? A prism is a prism. That doesn't change because now we're doing volume. So if we are looking at this figure, with these dimensions, then we still have to decide what figure are we looking at. It is a prism, but what shape would our base be? How can I tell that this is not sitting on its base? Well, I can see the two triangles, and triangles cannot be lateral faces in a prism because the lateral faces have to be the rectangles, which mean your lateral faces are this way, and my bases are the two triangles.
Yeah.
So the nice thing about volume is we really only need to consider one base because it's base area times height. And you're inserting whatever formula you need to use to find that base area. So if the base is a triangle, you use the area of a triangle. If the base is a square, use the area of a square. If it's a circle, in the case of a cylinder, we use the area of a circle. So it's kind of nice. We don't really have to designate that much between the prisms and the cylinders because you just put in the correct area of the base. So in this case, our base being a triangle, we need 1/2 the base and the height of the triangle times the height of the prism. The only problem is, in our triangle, do we have the right dimensions? On my triangle, do I have the base and the height of the triangle? I don't. The base and the height need to be perpendicular. So I could count 20 as the base, but I really need to find this part right here. How do I do that? Pythagorean theorem. So 29 is the hypotenuse. It needs to be by itself. So we'll do that up here. 29 squared equals 20 squared. We'll call that little h because that's kind of what we're looking for anyways. Plus h squared, which is 841 equals 400 plus h squared. Subtract 400 and we get 441 equals h squared. Take the square root. So h is 21. Okay. Okay, so there's my height of my triangle. So we have 1/2 times 20 times 21, that's the area of the triangle, times the height, which is, what's the height of my prism?
40.
It is 40, the distance between the bases. And if you plug this all into your calculator, you get 8,400, and that is volume, so it's cubic inches. Okay. Someone said in another hour they think whenever they get numbers that big that they did something wrong. But remember, this is volume, and you're dealing with 3 multiples of 10, so you should be in the thousands, yeah. Okay. One more triangle or one more prism to talk about, and this does appear in the homework.
I really want to see what the mess of the units now. Squared and cubed.
Yeah, you really have to watch the units and consider what you're finding, because some of these problems will have you actually go back and find a length, and that's in regular units, and then an area is in square, and the volume is cubic.
Are they going to do like any one of those given the volume on a surface area?
Not in the prisms or cylinders or things like that. I think it's more once you get in spheres, that you take the volume and go back and find the radius so you can plug it in to find the surface area, or vice versa. So, all right. So the reason I wanted to look at this one is your base is a triangle. Your big H is the 10, but you're missing a height. Okay? This is good exam review. It's an equilateral triangle, so how can I go about finding the height? If
That's
I,
the height of 10.
the height of the prism is 10, but I need the height of the triangle. So, well, this is 4, and each angle is 60, which makes this 30.
You have to do special, right?
It's a special right, and across from 60 is the x radical 3. So remember, it's 4 radical 3. So when you have an equilateral triangle, the height is half the side length times the radical 3, using the special rights. So my volume would be my base area times my height. My base is a triangle, so it'd be 1/2 base and height of the triangle. So that would be 1/2 times 8 times 4 radical 3 times the height of the triangle, which is 10. And you'd get to do this one to the nearest tenth or the nearest whole number. We'll just say the nearest whole number on this. So you get to use your calculator. So if you plug all that in, you should get 277. We'll call that inches. Yeah.
Oh, sorry.
That's it.
I was right here to look that one. I didn't have
Oh, all right.
it.
All right, we're going to apply what you've learned to cylinders.
These are easy to learn. So these are... Isn't it just circumference times the height?
Not circumference, but it's your circle.
The area of the circle, which
Yeah.
is pi.
Okay, so area of a circle, and that's why I say your base area, if you can remember base area times height, those base areas are interchangeable. Whatever your base shape is, you plug the correct area formula in. So the base is a circle, so it's pi r squared, times the height, which you could put 8 in at any point. But. Okay, the radius is 3. So this would be pi times 3 squared, which is 9, times 8. And if you get to leave your answer in terms of pi, what is your answer? Mm-hmm. 72 pi cubic inches. And we probably will not give you a polygon base to do volume with. The most we would make you do is maybe lateral area, but we're not going to make you do the area of polygon times the height. So you could. We could ask you to do it because you just finished a test on it not that long ago, but we're probably not going to. Okay. But know that you can. The other thing I want to point out is I don't think these have come up yet, but just in case they do, okay, this is a right cylinder. This is oblique. And I know you guys are panicking a little inside, don't. Okay, there's really not a difference. Let me show you why. Think of a stack of paper, like several reams of paper, all stacked up, straight, right, okay? That has volume. If I were to take that stack and push it over so it looked more like this, it's the same volume as it was here. The only difference is when you push this over, it's going to get longer, right?
Oh,
The paper spreads out.
so do we have to find
So you need this height.
Yeah.
That is your height, not the side length. That's the only difference between an oblique prism or cylinder and a right.
It's still more work.
But they're going to give you that.
Oh, yeah, right. Then I'm happy.
If they didn't, you'd need this length right here in order to do the Pythagorean theorem. So this just has to be at a right angle. But they're going to give you that. So volume is still base area times height. Just the height is the vertical height, not the side length. Okay, so your radius is 4. base area is pi r squared. So this would be pi times 16 times 16, or 256 pi. We'll call it meters. So, not a big deal. Alright, there's one more problem. Still not reason to panic, but you know how you guys learned a while back how to do areas of irregular figures, and you had to split them up, find one area, find another, add them together? Yeah. In 3D, they're called composite figures. And I'm going to record that.